Google's quantum AI scanned 3-eye atlas images, and the results are nothing short of terrifying.
For years, Oumuamua has been one of the greatest mysteries in space. Discovered in 2017 as the first confirmed interstellar object to pass through our solar system, it left scientists with more questions than answers. Its unusual cigar-like shape, strange tumbling motion, and unexplained acceleration puzzled astronomers everywhere. Was it a comet, an asteroid, or something far more extraordinary? Until now, all we had were surface-level observations. But for the very first time, researchers have been able to look inside this visitor from another star. Using powerful quantum AI, scientists created a detailed internal model of Oumuamua, something no traditional computer could achieve. Instead of guessing from its odd shape and movements, this new method let them peek into its hidden structure. What they found shocked everyone. The core of Oumuamua is not like anything seen in our solar system. It may hold exotic material or even signs of engineering. Forget what you thought you knew about this cosmic traveler. The first look inside Oumuamua doesn't just raise new questions. It changes the entire conversation about life and technology beyond Earth. Quantum AI breakthrough. The real turning point in this mystery came when scientists turned to quantum-powered AI. Unlike normal computers that test one scenario at a time, quantum systems can run millions of possibilities at once. This ability allowed researchers to build a complex internal map of Oumuamua using the tiniest pieces of data we had. Its path through space, its speed changes, how it spun, and how it reflected sunlight. Each of these clues was like a puzzle piece, and the AI combined them into a full picture of what must be inside. What makes this breakthrough so powerful is that it goes beyond old theories. Earlier models suggested Oumuamua was just an odd rock or a comet with hidden ice, but the quantum simulations revealed something much stranger. A dense and exotic core, spin patterns that looked controlled, and evidence of heavy internal layers. In short, this wasn't just crunching. It was the first true attempt to see beneath the surface of an interstellar object. With this breakthrough, quantum AI has opened a new door in space research, one that might forever change how we search for alien technology and cosmic secrets. A strange core revealed. When the quantum AI finished running its simulations, the first shock was clear. Oumuamua's core is nothing like the objects we know in our solar system. Instead of being made of ordinary ice or rock, the data showed a dense, exotic center wrapped in lighter material. Imagine a pebble with a heart made of something heavier than lead, something science cannot yet explain. The models consistently pointed to this unusual mass concentration, no matter how many tests were run. This core could be made of rare cosmic matter, maybe fragments of a dead star, or it could be something even more extraordinary, an engineered structure. For scientists, this was the moment that changed everything. The mystery of Oumuamua wasn't just about its long shape or strange spin anymore. What lay inside might hold the answers. A dense, hidden heart that didn't match natural patterns suggested that our first interstellar visitor carried secrets far beyond what telescopes ever showed us. With this strange core revealed, researchers realized they were not just studying a rock from another star. They might be looking at a clue to something greater. Not just shape, but inside. For years, all we knew about Oumuamua came from its outward appearance. Telescopes showed a long, thin body, maybe like a cigar, maybe like a pancake, tumbling strangely through space. Its brightness changed in ways that hinted at an extreme shape unlike anything in our solar system. But scientists now realize that its exterior was only half the story. The real shock came when the quantum AI looked deeper. What mattered most wasn't how Oumuamua looked on the outside, but what was hidden inside. Beneath its scarred surface, the AI detected layers of material with different densities, wrapped around an unusually heavy core. This explained why its movement through space didn't match simple gravity or normal comet behavior. Instead of being just another cosmic rock, Oumuamua turned out to be far more complex. Its strange acceleration, its tumbling spin, and even its survival after traveling across interstellar space. All these clues now made sense only when the inside was revealed. Scientists are beginning to see that the real mystery of Oumuamua is not its odd shape, but the secrets locked within its core. Engineered or exotic? The question now haunting scientists is simple, but unsettling. Is Oumuamua a product of nature, or could it be something engineered? The quantum AI findings point in two possible directions, and both are extraordinary. On one hand, the dense and unusual core could mean Oumuamua carries exotic matter, substances like fragments of a neutron star or other stellar debris, things so dense a teaspoon would weigh tons on Earth. If true, it would be the first time we've seen such material wandering into our solar system. On the other hand, the strange spin patterns and the layered internal structure suggest something more artificial, like a spacecraft or probe that has drifted for eons. Its motion resembled partial spin stabilization, a technique we humans use to steady satellites. Could this be coincidence, or is it a sign of intelligent design? Scientists remain cautious, but the data refuses to fit neatly into natural explanations. Whether Oumuamua is exotic matter born in the death of a star or an engineered relic from an unknown civilization, either answer would change our place in the universe forever. What the AI found after running millions of complex simulations, the quantum AI uncovered three key findings about Oumuamua that stunned scientists. First, it revealed a dense and exotic core, unlike the ordinary rock and ice we find in asteroids or comets. This heavy center was surrounded by lighter layers, suggesting a structure far more complex than a simple space rock. Second, the AI detected signs of artificial spin stabilization. Instead of tumbling randomly, Oumuamua's motion showed patterns similar to controlled spinning, a technique used in spacecraft engineering. Over time, this spin may have destabilized, but its fingerprints remained in the data. Finally, the AI proved Oumuamua is not hollow, dismissing earlier theories that it might be like a thin light sail. Instead, it holds significant mass inside, layered in ways that don't match natural formation models. These findings, taken together, suggest Oumuamua is more than just a strange visitor from another star. It may be a fragment of something exotic, or even evidence of engineering. For the first time, humanity has a glimpse inside, and what the AI found is rewriting everything we thought we knew about this cosmic messenger. Three big discoveries. When scientists reviewed the quantum AI results, three discoveries stood out as the most important. The first was the presence of an extremely dense core. No matter how many simulations were run, the data kept showing a concentrated center of mass that didn't match any normal asteroid or comet. The second discovery was even more surprising. Oumuamua's spin was not completely random. The AI detected signs of artificial spin stabilization, the same method engineers use to keep satellites steady in space. It looked as if something, or someone, had once tried to control its rotation, though time and distance may have weakened that effect. The third discovery closed the door on old theories. Far from being hollow, Oumuamua carried layers of mass within it, heavy material at the center and lighter layers outside. This ruled out the idea of it being a simple light sail or empty shell. Together, these three findings revealed that Oumuamua is not just unusual. It is extraordinary. Each clue points toward something our solar system has never seen before, leaving scientists to wonder if this was nature's strangest creation or evidence of something built. Dense core mystery. The most striking clue uncovered by quantum AI was the dense core buried deep inside Oumuamua. Unlike ordinary comets or asteroids, which are mostly ice, rock, or mixed rubble, this interstellar visitor appeared to hide something far heavier at its center. The simulations consistently showed a compact mass that threw off all expectations. Imagine holding a stone that looks normal on the outside, but inside lies a weight far greater than anything you can explain. Some scientists suggest this could be exotic matter, fragments of a neutron star or white dwarf, material so dense that a spoonful would outweigh mountains. Others wonder if the core could be engineered, designed with purpose, layered with precision. This unusual density also explains Oumuamua's odd path through our solar system. Its acceleration, its strange tumbling spin, even its resistance to breaking apart after traveling light years. All of it could be traced back to this hidden heart. But what exactly is it? A shard of a dead star or a relic of technology? The mystery of this core remains unsolved, and it is the key that may decide whether Oumuamua is natural or something far beyond that. Signs of spin control. One of the most puzzling details revealed by the quantum AI was Oumuamua's unusual spin. At first, astronomers thought its tumbling was completely random, the kind of chaotic motion you'd expect from a rock knocked around in space for millions of years. But the data told a different story. The AI detected patterns in its rotation that looked strangely familiar, similar to spin stabilization, a method humans use to keep spacecraft steady. In engineering, we deliberately spin satellites or probes to help them maintain orientation. Oumuamua's spin showed traces of the same idea, as if it had once been carefully controlled, but later drifted into partial instability. This discovery raised serious questions. Could nature really create such a motion by chance, or was it evidence of something artificial? The thought that an object from another star might carry the fingerprints of intelligent design is both thrilling and unsettling. Even if the stabilization broke down over time, the remains of its pattern still linger. For scientists, these signs of spin control may be the strongest hint yet that Oumuamua is not just a cosmic rock, but possibly an artifact. Not hollow after all. For years, one popular theory about Oumuamua was that it might be hollow, like a thin light sail drifting through space. Some scientists imagined it as a sheet-like structure pushed by starlight, which could explain its strange acceleration without visible gas or dust. But the quantum AI has now put that idea to rest. The simulations revealed that Oumuamua is anything but empty. Instead, it holds significant mass inside, packed in layers of different densities. At its heart lies the dense core, surrounded by lighter outer material, forming a solid, complex body. This discovery means Oumuamua is not a fragile shell, but a sturdy traveler capable of surviving the harsh journey between stars. Its acceleration cannot be explained by a hollow frame. It must come from something deeper within. This finding also raises the possibility that its structure is not random but purposeful, maybe even designed. Whether built by natural forces or by intelligence, the fact remains Oumuamua is not hollow. It is full, heavy, and far more mysterious than anyone first believed. This revelation forces us to rethink what this interstellar messenger truly is. How AI saw inside, you may wonder. How can scientists look inside an object millions of miles away, one we only saw briefly as a moving speck of light? The answer lies in the power of quantum AI. Instead of physically scanning Oumuamua, researchers used its behavior as a kind of cosmic fingerprint. Every detail, its strange path through space, its acceleration without visible outgassing, its odd tumbling spin, and how it reflected heat and light, was data. The quantum AI ran millions of models, testing countless possible internal structures, until only the most likely ones remained. Think of it like following footprints in snow to guess the shape of the shoe, but on a far more advanced scale. By analyzing gravitational anomalies, heat signatures, and light bending effects, the AI created a virtual map of Oumuamua's insides. This method didn't require direct observation. It used the subtle clues left behind as the object passed through our solar system. For the first time in history, humanity could see not just the outside of an interstellar visitor, but also its hidden interior. And what was revealed was stranger than anyone expected. Tracking path anomalies, one of the most important clues, came from Oumuamua's path through space. Normally, an object moving past the sun follows a course set only by gravity. But Oumuamua didn't. As it traveled, it drifted slightly off the expected path, as if pushed by an invisible hand. Traditional explanations suggested outgassing, jets of gas from melting ice, like a comet's tail, yet no telescope ever detected a trace of gas or dust. This left scientists puzzled for years. The quantum AI revisited every bit of tracking data, analyzing the tiny deviations down to the millimeter. By working backward, it built models of how internal mass must be arranged to cause those movements. Imagine looking at tire tracks in mud, some deeper, some lighter, showing how weight was spread. The AI did the same, but with a cosmic traveler moving at 26 kilometers per second. These path anomalies proved Oumuamua wasn't just a simple rock. Its hidden mass, especially the dense core, was directly shaping its journey. What seemed like random drift now looked like evidence of something unusual inside, something that ordinary models could never explain. Heat maps of the core. Another powerful clue came from how Oumuamua handled heat as it passed near the sun. Different materials warm and cool at different rates. Metal conducts heat quickly, while ice and rock respond much more slowly. Using data from the Spitzer Space Telescope, scientists tracked faint changes in infrared light as Oumuamua absorbed and released heat. Then, the quantum AI used this information to build a thermal map of the object's interior. The results showed clear signs of layered material, with dense regions carrying heat differently than the outer shell. It was like aiming a thermal camera at a wall and seeing the hidden studs inside, except in this case, the wall was an alien visitor racing through space. The findings ruled out the idea that Oumuamua was a uniform block of rock or ice. Instead, it revealed a complex structure with a dense, exotic heart wrapped in lighter layers. This heat analysis confirmed that the mystery was not only in its odd shape or strange motion, but also in its very composition. The thermal fingerprints pointed straight to an extraordinary core unlike anything seen before. Light-bending secrets, perhaps the most fascinating technique used to probe Oumuamua, came from a phenomenon called gravitational microlensing. Even small objects in space bend light from stars behind them, creating faint distortions almost impossible to see. Normally, this effect is used to discover distant planets, but the quantum AI applied it on a much smaller scale. By scanning archived starfield data from the time Oumuamua passed through our solar system, the AI searched for tiny flickers, subtle bends in starlight caused by the object's mass. Piece by piece, these distortions built a kind of density map, revealing how weight was distributed inside. What emerged was stunning: a compact, heavy core wrapped in lighter material, consistent with the other methods of analysis. It was as if the universe itself had drawn a shadowy outline of Oumuamua's hidden heart using starlight as ink. For the first time, scientists weren't just relying on motion or heat. They were reading the object's effect on light itself. These light-bending secrets confirmed what the other models suggested: Oumuamua's interior was far from ordinary, pointing again to something exotic or possibly engineered. Quantum power explained, the reason this discovery was even possible lies in the unique power of quantum computing. Unlike traditional computers, which test one possibility at a time, quantum systems explore millions of outcomes simultaneously. They do this using qubits, which can exist in multiple states at once. For Oumuamua, this meant the AI could take every scrap of data, its path, its spin, its heat, its light distortions, and run countless models in parallel. Each model represented a possible interior structure. The AI then compared these simulations with real observations, discarding the ones that didn't match until only the most likely scenarios remained. In effect, it acted like a cosmic X-ray, peering beneath the surface of something we could never physically touch. Without quantum computing, scientists would still be stuck debating wild guesses. Instead, this technology gave them the first real evidence of a dense, exotic core and layered structure inside Oumuamua. Quantum power didn't just make the impossible possible. It opened an entirely new way to study interstellar visitors, a tool that may forever change how humanity investigates the mysteries of the cosmos. Exotic matter possibility. One of the most thrilling ideas raised by the quantum AI analysis is that Oumuamua might contain exotic matter. This isn't just rare rock or unusual metal. It could be material formed in the heart of a dying star. Imagine a piece of neutron star crust or white dwarf core so dense that a teaspoon of it would weigh billions of kilograms. The models show a core with extreme density, far beyond anything in typical asteroids or comets. If this is true, then Oumuamua may be the first confirmed fragment of a dead star ever to visit our solar system. That would make it not just strange, but historic. It would also explain many of its odd behaviors. Its acceleration, its ability to survive deep space, and its strange spin. Exotic matter like this could carry unique properties, such as rare isotopes or strange magnetic interactions, that don't exist naturally on Earth. If scientists can study it further, it might reveal secrets about how stars die and what survives afterward. More than that, it proves our galaxy may be full of incredible debris, ancient pieces of stellar history drifting between the stars. Could it be alien? This is the question scientists are now daring to ask. Could Oumuamua be alien? The quantum AI didn't just find strange materials. It uncovered motion patterns that seem too precise to be random. Its spin isn't wild and chaotic like debris from a natural collision. Instead, it shows signs of partial spin stabilization, a method engineers use to keep spacecraft balanced. Over time, the control may have broken down, but the original pattern still remains, like the faded echo of intelligent design. Combine that with the layered structure, the dense core, and the unexplained acceleration, and suddenly, this object looks less like a rock and more like a relic. Maybe it's a probe, or even just technological debris from a long-dead civilization. Of course, scientists are cautious. They're not saying it's alien, but they are saying the data fits both natural and artificial explanations. And that's what makes Oumuamua so special. It's not proof of life beyond Earth, but it might be the best candidate we've ever found. The idea that we may have already encountered an artifact and simply watched it sail away is both exciting and haunting. A piece of another star. What if Oumuamua is more than just a mysterious object? What if it's a literal piece of another star? The quantum AI data suggests that the dense core inside could be made of exotic materials only formed in the most violent parts of the universe, like the crust of a neutron star or remnants of a white dwarf. These are places where atoms are crushed together under incredible pressure, creating matter unlike anything found on Earth. If Oumuamua is made from this kind of material, then it may have once been part of a star that exploded or collapsed, flung out into space during a cosmic event billions of years ago. And somehow, after traveling untold distances across the galaxy, that fragment ended up flying past our sun. This idea is staggering. It means we didn't just see a visitor from another star system. We may have seen a visitor that was part of another star. Holding something like that would be like holding the ashes of a supernova in your hands. It's a reminder that space isn't just, it's full of history, waiting to be discovered, comparisons with others. To understand how strange Oumuamua truly is, scientists compared it to the only other confirmed interstellar visitors. 2I Borisov and 3I Lus Borisov, discovered in 2019, looked and behaved just like a typical comet. It had a visible gas tail outgassing and a predictable path. In fact, if we hadn't tracked its orbit, we wouldn't have known it came from another star. On the other hand, Atlas, discovered in 2025, is much larger than Oumuamua, and while it's not as bizarre, it does show a few strange traits. It seems to sit somewhere between normal and unusual. But Oumuamua stands apart from both. no outgassing, no visible tail, a strange shape, a chaotic spin, and now, thanks to quantum AI, a dense core and a structure never seen before. If most interstellar objects are like Borisov, then Oumuamua is clearly an outlier. That makes it even more mysterious. Why is the very first object we saw from another star also the strangest? Either we were incredibly lucky, or Oumuamua was meant to be found. And that's a question science hasn't yet answered. SETI 2.0 begins for decades. The search for extraterrestrial intelligence, SETI, focused on listening for radio signals from space. Scientists hoped that one day we'd catch a message sent by an advanced civilization. But Oumuamua may be changing that approach. Its strange behavior, dense core, and possible signs of artificial design suggest that alien technology might not speak, it might travel. What if instead of signals, the real evidence of alien life is silent, drifting between stars as physical artifacts? This idea is giving birth to a new way of thinking, SETI 2.0. Instead of just listening, we now look. Quantum AI is helping to scan and study interstellar objects in ways never possible before. Missions are being designed not just to observe, but to intercept and investigate these cosmic visitors. We're shifting from waiting for contact to actively searching for clues. SETI 2.0 is about finding the footprints of intelligence, not just the voices. And if Oumuamua was truly a sign, natural or not, it may be the first hint that we've been looking in the wrong place all along. The next visitor could hold the answers. Next missions planned, the mystery of Oumuamua has inspired a new wave of missions designed to chase down the next interstellar visitor. Scientists now know that these objects don't just pass by once. They're part of a larger cosmic population. The question is, will we be ready next time? One plan is Project Lyra, which aims to launch a high-speed spacecraft capable of intercepting fast-moving objects like Oumuamua. Using solar or nuclear propulsion, it could reach speeds over 70 kilometers, fast enough to catch up with the next mystery. Another effort is the Comet Interceptor mission by the European Space Agency. Set to launch in 2029, it will sit in space, waiting in hibernation until a new object appears. Once detected, it will wake up and race to meet it. Meanwhile, the Vera C. Rubin Observatory, with its massive telescope and 3.2 gigapixel camera, will scan the sky every few nights, giving us early warnings months in advance. Together, these tools form the next generation of exploration. For the first time in history, we may be able to intercept an object from another star and uncover its secrets before it disappears forever. A cosmic mystery remains even with quantum AI.